Okay, so now we're going to use the calculator to solve an application type problem graphically. So in this problem, we're given a function of t, s. So this represents the height of a projectile that's launched from the ground, okay? And this is in meters per second. So the height, the position s is in meters, t is in seconds, okay? So based on this quadratic function, we want to know two things. When will the projectile hit the ground? Okay. And how long does it take for the projectile to reach 45 meters above the ground? So those are the two questions, and we're going to answer both those questions using the calculator. So the first thing we need to do is put this in the calculator. Okay. So again, it's already in the standard form, so I can say y1 equals this thing. So I'm going to go to y equals, I'm going to plug in negative 4.9 t squared, but in this case I'm just going to use x. So t squared plus 38t. And so this is what I have in the calculator. Okay, and this is what you should have in the calculator. So now I'm going to graph this thing. Okay, but before I graph it, again, I need to figure out what the window is going to be. Okay, so again, there's no constant term, but there's an a and b term here. Okay, so we know that obviously time has to be positive, so time is going to go from 0 to infinity. So x is going to, I would start at 0. But what about the range? Okay, well, in this case I'm going to use the calculator. So let's quit out of this. So I'm just going to do my a and b, right? So because well, you know what? Well, okay, so if I do x equals negative b over 2a, right? So again, b is equal to 38, and a is equal to negative 4.9. Okay, so if I do negative b, which is 38, so it would be negative 38 divided by 2 times negative 4.9, and I get approximately 3.88. So I know that, and then of course if I put 3.88 in here, I get something that's positive, right? So you're always above ground level, right? So I know I'm going to be in the first quadrant, right? That's the point I'm trying to make, is if you read the problem carefully and you understand the concept, you already know that you're going to be in the the first quadrant of this thing. So let's just do that. So let's do the window, and I'm going to just stay within the first quadrant. So I'm going to go -1, and let's do 15 for max, and then y minimum is going to be 0. And let's do 100 for y max. Okay. Okay, so let's use this and see what we get. So if I graph it, not bad. Okay, not bad. So now if I adjust the window, if I just adjust the window, so I don't need to go that far out. So let's do 10. And let's do 75. Look at that. Okay, so again, you could play around with the window. And so this is the graph I have. This is what I'm going to use. Okay? And now, let me just change it one more time. Let's go to -3 for y, just to make sure I get everything on there. Okay, so there's my graph. Now, let's answer the questions. When will the projectile hit the ground? Well, the projectile will hit the ground when, what? The height is 0. So that means I'm going to look for the x-intercept. So let's do that. So let's go to second calc, and let's go to 0, right? We're going to go to 0. And now I'm just going to, now I don't want this 0. We know it starts at ground level. I want this 0, okay? Because we know it starts at ground level. It's being launched from the ground. So it's going to stay up in the air and it's going to hit the ground over here. So I want to know what that x value is here, this t value, right? Time. So let's do that. So oops. So now let's go over here. I'm going to go all the way to here, right? I want this side. And now I'm going to keep going till I'm below, right? And I know I went below because this is negative, okay? So now I'm going to hit enter again. And now I want my guess. Okay, and I'm going to hit enter. And look at that. So it gives me an x value 7.76. So approximately 7.76 seconds. So this is 7.76 seconds after launch. Okay? So now, what about the second one? Is this, how long does it take to reach 45 meters above the ground? Okay, well, how am I going to do that? That's a good question. So here's the way you're going to do it. I'm going to plot another line. I'm going to plot a line that goes across. Well, what line do I need to find? Well, I need to find what the value is this thing is at 45 feet above the ground. When is this thing 45 feet above the ground? So I want a horizontal line right at 45. So let's go back and do that. So let's go to y equals, and for y2, I'm just going to write y2 equals 45. So let's just do that. Now I hit enter, so there we go. Now watch what happens when I graph this. So now, look at that. Now what do I need? Well, right where this horizontal line intersects the parabola, that is exactly when or where the rocket reaches 45 meters above the ground. So all I have to do is find where this intersection point is and where this intersection point is. And so how do I do that? Well, let's go to second calc. And now look at that. I'm going to go to number 5, which is intersect. I want to find the intersect. So let's go down to 5, hit enter. And this is, now there's my cursor up there, so I need to find the left and right endpoints of this and this. So let's do the first one. So again, I'm going to put my cursor on the left, like so, and then I'm going to hit enter, and then I'm going to put my cursor, on the second curve, right? So it said first curve, now it's saying second curve. So look at, I am on the second curve, right? So I'm going to hit yes. And now it's asking me for my guess. Where does it intersect? So let me guess right about there. And so notice what I get. I get y equals 45 when? when x is 1.458 or 1.46. So that would tell me it reaches 45 meters 1.46 seconds after launch. Also, because whatever comes up or goes up must come back down. So it also reaches 45 when it's on its way back down. So let's do it again. So we're going to do second, trace. We're going to choose intersect. And now I'm going to go over to here. So here's my first curve. So I'm on the first curve, right? So the first curve, and now the second curve, and now I'm going to go over to my guess, right about there. And I'm going to hit enter. And now what do I get? I get x equals 6.29 or 6.30. Okay, so 6.30 seconds after launch. Okay, and that's it. Have a great day.